Hello, this is Michael Capuana, James Curtis, and Nate Ficuri presenting on our Avalanche rescue vehicle for our ECEN 361 project. In an avalanche situation, the vehicle usually has about 18 minutes of air before dying of suffocation. As a solution to this problem, we wanted to create a robot that could find a victim quickly and supply them with air while the victim waits for ski patrol to dig them out. Our robot consists of a motorized chassis with a Raspberry Pi 3 that contains all of the instructions for where the vehicle should move. We also used a Raspberry Pi Robot Board V2, which is used to power the motors and govern the directions to move that are sent from the Raspberry Pi 3 to the motorized chassis tracks. The battery we used to power this vehicle is a 12-volt LiPo battery. We then used an RF receiver that could pick up the frequency of an alerting signal along with an ADC Pi Plus, which was used to convert that signal from analog to digital so that we could use that frequency strength and code our Raspberry Pi 3 to keep going toward the signal as it grew stronger. The biggest challenge we had during this project was determining the correct hardware to use. All three of us are computer science majors and had no experience with any of the hardware mentioned above. We also had to learn everything from the ground up. We faced a lot of challenges with interfacing with some of the hardware due to it being either undocumented, such as our chassis and our initial RF transmitter and receiver, or deprecated, such as the ADC Pi Plus, which has been replaced and no longer offers any documentation. The last struggle we had was reading a strong and consistent signal with our RF receiver. We used an RF transmitter to put out the signal, which was problematic due to it not being an amplified signal, so it was not strong enough to transmit more than a couple of feet. Even within those first couple feet, the signal was never very consistent, which made it difficult to accurately read the signal strength and program the vehicle to move closer as the signal got stronger. Although we faced a lot of challenges, we had a lot of success. We learned a ton about the hardware and how to interface with everything that we used and get the vehicle moving, as well as determining which parts would need to be used if we were putting it into production. We were also able to prove that we could measure the signal strength sent by the RF transmitter and be able to get this vehicle to move closer to the transmitting signal. Thank you for your time.